Okay, so in the last class we talked about line integrals, right, along certain curves. Uh, I'm going to give you today a couple of examples, and I think if time permits, probably I can talk about double integral. So you will see that a double integral, I mean, of course, definite double integral is nothing but a volume. Okay, just like that we have a in a single variable case, if there is a curve, right, and if you integrate a to b f of x dx along that curve, y is equal to f of, I mean, uh, integrate the function f of x. So basically the area under the curve from x equal to a to x equal to b can be written like this definite integral. Similarly, you will see that same ideas, similar ideas, we can take it and we can define what is known as double integral. So integration a to b and integration c to d, f of xy dx dy, and that looks nothing but, because you see, because now it's a two variable function, so there is a surface and the volume under that surface represents, so that idea is straightforward, in a straightforward manner generalizes to volume. Okay, so then we are going to do couple of examples of double integral, and then you see then we can talk about Fubini's theorem, which says that the order of integration when you can change, okay, because there are two integrations, right, a to b, c to d, which one to do what and how. There are certain conditions when you can do that, and also then we are going to talk about connection between line integral and double integral, okay, and that is known as Green's theorem. Basically, it's a very nice thing. And then you see that this line integral, we call it integration along c p dx plus q dy, where p and q are functions of two variables, connects to a double integral, and that's a Green's theorem. It's a very popular theorem, and actually using this we can define, so when we talk about complex line integrals, they actually take this kind of form, and then we can apply Green's theorem, and we can find certain properties of complex line integral directly. So that is an idea how we are going to approach. So yeah, so this was normal real integral, right? This is the formal definition. Then we talked about certain types of curves, and then line integral in the plane. So we form these kind of sums. So basically the line integral of a two variable function gxy along c with respect to x is given like this, right? And similarly with respect to y, it is given like this, and with respect to arc length we define three kind of line integrals. This is for the arc length. Okay, now in order to find these ones, if c is a parametric curve, means you can do the parameterization. Okay, so then formula becomes this, right? Because when x is a function of xt, y is a function of yt, then first formula becomes something like this, because then g of xt yt, when you substitute x equal to xt, y is equal to yt, then you need to also take care of dx over dt times dt, right? That is whole thing for along x, along y, and along the arc length, because this quantity is nothing but ds square. Or small, if you draw a small triangle, actually they follow, dx over dt whole square plus dy dt whole square is equal to ds over dt whole square, right? So this whole thing. So basically these are the simple formulas, and I think we have done some examples. Integration along c xy square dx when C is this circle, okay, along Y and along arc length S. Okay. Now I am going to tell you the formula for the other part, case B. Case B. Now, in earlier case, when we can do the parameterization, then I told you how to do it. But if it is some sort of equation, then what to do? Then dy is nothing but f dash of x dx, and I can use the formula that ds is equal to 1 plus f dash of x whole square times dx, and hence the formula becomes integration along C gxy dx becomes a to b g of x comma f of x dx. So y we have substituted with f of x, right? Similarly, integration along C gxy dy a to b g of x comma f of x f dash of x dx. And then the last one we have integration along C for the arc gxy ds is equal to a to b g of x comma f of x. I have substituted y is equal to f of x is square root of 1 plus f dash of x whole square dx. Okay, so these are the three formulas. When you cannot find the parametric, then you can actually use these directly substitution of these in these equations. Okay. Now another interesting thing to note, integration along C g of xy ds. If C is a piecewise smooth curve, means something like this I showed to you, piecewise smooth curve like this, right? So the path is consisting of several curves like C1, C2, C3, piecewise smooth, right? For each piece is a smooth curve. Then this is nothing but for each curve. So I am just saying, suppose 2 g of x comma y ds plus integration along C2 g of xy and ds. So you can break the integral for each piecewise smooth curve. Okay, that is the thing. Okay, now some notations, and these are quite useful notation actually. Integration along C p of, so if we have integration along C p of xy dx plus integration along C q of xy dy. So basically we have p and q are two functions, two variable functions, and I am computing this line integral along x of pxy and along y of qxy for some other function. So I can write it down in a shorthand notation. This is nothing but integration along C p of xy dx plus q of xy dy. Right. I don't have to basically again write integration sign twice, right? In fact, in a more shorthand form, I write it like simply integration along C p dx plus p dx plus q dy. So this is the shorthand notation where you understand that p and q are two variable functions, And this integral you have to evaluate on both, right? P and Q separately, right? So shorthand. So this is nothing but this whole quantity can be written nicely like this. Okay, shorthand notation. Also another shorthand notation. A line integral along a closed curve C. C is denoted by integration along C P dx plus Q dy. Okay. So basically I am saying I am introducing this notation. A circle on the integration means along a closed curve. C is a closed curve. Okay. And then everything remains same. This is also a line integral. Okay, so let us take example. Now I am going to do a couple of examples. Compute this value xy dx plus x square dy, where C is a curve. So C is, what is C basically? Graph of y is equal to x cube, and where x lies between -1 and 2. So somewhere here there is a point -1, -1. Somewhere there is a point 2, 8. So approximately, I am not very good at drawing the pictures. Forget about this. This is our curve C. Y is equal to x cube, starting from this point going up to 8. I can say that for that corresponding point anyway. So now I have to compute this integration along C xy dx plus x square dy, and graph of the curve is y is equal to x cube, where x starting from -1 and going up to 2. So now since y is equal to x cube, we know that dy will be what? 3x square dx. So the whole integration C xy dx plus x square dy. I think I should write it in a fresh picture here. So integration along C xy dx plus x square dy is equal to so what we are doing, since dy is equal to 3x square dx, so actually there is no y, right? So only the integration sign will be along x. So x varies from -1 to 2. So this will be -1 to 2 x times x cube dx plus x square 3x square dx, right? And this you can simplify, -1 to 2, 4x to power 4 dx is equal to 132 by 5, right? Once we substitute y is equal to x cube, so dy is there. Now everything to be integrated from along x, right? X is varying from -1 to 2. Just substitute it and then simplify, right? Fairly straightforward. Okay, so now do another example. Now I have to integrate along a closed curve C. C is a circle defined by x is equal to cos t, y is equal to sin t, and t varies from 0 to 2 pi. So one circular thing, right? Okay. Now in this case, what I need to do? So there is a parametric equation, right? So since x is equal to cos t, this implies that dx is equal to minus sin t, dx is equal to minus sin t dt. By the way, a rough guess without calculation, what could be the value of this, a rough guess of this integral along the closed curve? Huh? Any random guess? Let me see. It's a very important one, but any guess, what could be the value? Who said 0? Calculate kar liya ya you got it? I mean, there is a reason why it is 0 actually, but anyway, I wanted to ask you to think why it is 0, but anyway. Let me show you it is 0, but actually later on I will tell you why it is 0, right? Anyway. Okay, so this value is 0 anyway. So let us see why. So we have integration along C x dx 0 to 2 pi cos t minus sin t dt, and this is nothing but half of cos square t 0 to 2 pi. This is half times 1 minus 1 and is 0. Right. So I hope you know how to do these calculations. Fairly straightforward. Just do the substitution and do the calculations, right? So integration along a closed curve C, in this case circle, the value of this integral is 0. Okay, take another example. Again a closed curve, y square dx minus x square dy. Curve is defined like this. Starting from 0, 0, somewhere there is a point 2, 0, and somewhere here. So this is your C1, this is your C2, value is 2, 4, and this is C3. And actually this curve is nothing but y is equal to x square. So look at this, this is a closed curve consisting of 3 curves. C1, straight line from here to here. C2, again a straight line from here to here. And the curve y is equal to x square, starting from 2, 4 to going to 0, 0. So this is how the closed curve is complete, right? Okay. Now I have to find this value. तो कुछ मुश्किल नहीं है. Whole curve C can be decomposed into C1, C2, C3. So I am going to do that along C1, along C2, along C3. 3 integrals will be there, right? Since C is equal to C1 union C2 union C3, so this integration along C is nothing but integration along C1, integration along C2, integration along C3. Now on C1 what happens? On C1 y is equal to 0. On C1 y is equal to 0, right? And so dy is equal to 0. right? So what is the overall value? So this C1 of whole thing will be 0, right? Because y is equal to 0 and dy is equal to 0. So this whole expression what I am talking about will be 0, right? I can write down here the value y square dx minus x square dy. Whole thing is 0, right? Fine. On C2 what happens? Now on C2 actually y is a parameter, and basically so y is, I would say you can take it as a parameter, but x is equal to 2, that line x equal to 2 is fixed, and so dx is equal to 0, right? X equal to 2 is fixed, so dx is equal to 0. So what will be the simplification here? Along C2 y square dx minus x square dy will be what? 0 to 4 y square times 0 minus 4 dy. Do you agree? Why this is from 0 to 4? Because the y is changing from 0 to 4, right? So everything is there. Since x is equal to 2, dx is equal to 0, so this is 0, right? So this 4 goes off and you are left with so overall thing is actually minus 16. Okay. So along C1 what is happening you saw, along C2 you saw, C3 is now y is equal to x square, but you know in the negative direction actually, right? So now what to do with this? Okay, along C2 now, along C3, on C3 what happens? X is a parameter and y is equal to x square. This implies that dy is equal to 2x dx. So integration along C3 y square dx minus x square dy, this is what we want to compute, will be integration 2 to 0 x square whole square dx. Okay, because x is varying from 2 to 0, right? And then minus x square 2x dx. So whole thing you can simplify, this value turns out to be 8 by 5, right? I mean you can compute anyway. So therefore integration along C y square dx minus x square dy is equal to C1 along C2 along C3 is equal to 0 plus minus 16 plus 8 by 5 turns out to be minus 72 by 5. So I hope you got the idea how to compute along different curves, right? If curve is a closed curve and if you can decompose into several smaller curves along several paths along C1, C2, C3. So whatever is the situation on C1, you know y is equal to 0, you take care of that, right? C2, you know what is happening, right? X is fixed, x is equal to 2, so dx will be 0, and then the curve, right? Y is equal to, so you can just decompose into different portions and compute the value, right? So I think this whole value is, so there will be different kind of such kind of examples are there, but I think in your last assignment probably some of these calculations are given to you, right? You can look at it. So I think I have already announced that we are going to ask questions up to this portion in your exam, right? डबल इंटीग्रल हम बताने वाले हैं अभी क्योंकि वो पूरा हो नहीं पाएगा, इसलिए मैंने उसको बाहर कर दिया, ठीक है. बट एनीवे अभी तो डबल इंटीग्रल बताने का टाइम है, मतलब बट इट विल नॉट बी कवर्ड इन द एग्जाम, राइट. हालांकि कोई मुश्किल काम नहीं है, इट्स वेरी स्ट्रेट फॉरवर्ड. बट आई थिंक सिलेबस काफ़ी है तुम्हारे लिए ना अभी, एनफ, राइट. ओके. एंड आई होप गर्भा का खुमार उतर गया होगा, तो बेसिकली एग्ज़ाम का खुमार चढ़ गया कि नहीं. वो 30 तारीख को एग्ज़ाम है ना. ओके. एंड देन प्रोजेक्ट इज ऑल्सो, आई थिंक, आई होप सम ऑफ यू स्टार्टेड. प्रोजेक्ट के बारे में एक ख़ास बात यह है कि अनलेस यू स्टार्ट यू विल नेवर फिनिश. एंड एक जो हमारी ख़राब आदत होती है ज़्यादातर लोगों की, इंक्लूडिंग माई ऑल्सो, माई सेल्फ ऑल्सो, आई एम इंक्लूडिंग माई सेल्फ ऑल्सो, दैट लास्ट मिनट में करेंगे ना, एक दिन पहले, 2 दिन पहले. इट्स ए वेरी बैड हैबिट. और व्हाट हैपेंस, फिर क्वालिटी का काम नहीं होता है, राइट. सो इट्स बेटर यू प्लान. सी, इन डूइंग प्रोजेक्ट्स you should maintain a log, although I do not require it, but you should have a doc file with the way how to do the project. In the log file, each member should write their roll number, name, and their contribution on that day. If you just create a log, so I may ask this log file from anyone, although I don't want it, but because again there is a lot of work for me, but in that log, what you have done, right? Team formation, fala date, these are the members, right? Then on this date, so every day if you do only half an hour, 45 minutes contribution, you see by the end of actual submission how much work will be done. So we are not asking you to devote whole of your day, but what will happen, I know the usual practice towards the end, अरे भाई तुम ये कर लो, तुम ये कर लो, and then एक दिन के अंदर से finish करना है, सब खटाखट किया, इधर उधर चैट जीपीटी का सहारा लिया, राइट, एंड कॉपी पेस्ट करके लगा दिया. बिकॉज दिस इज ए लर्निंग एक्सरसाइज, एंड आई थिंक यू नीड टू लर्न हाउ टू राइट, you need to learn how to do presentation, PowerPoint. These skills are very, very important, and these are other than your academic skills, and I think in this course we are going to teach everything, right? So this is an important thing that you need to learn. How to present your ideas, PowerPoint कैसे बनाते हैं. If you are in doubt anywhere, please do and come and ask me or ping me, right? Ask me a small whatever query, because you have the WhatsApp number, you can send to me. But I'm saying that don't keep it till the last date. Keep a log file and just maintain the log file, right? This is a suggestion. कोई ज़बरदस्ती नहीं है. और एक्चुअली तुमको खुद ही पता लगने लगेगा, अरे आज तो मैंने 2 दिन से कुछ किया ही नहीं है, और सबको दिख रहा है, राइट. तुम्हारे ग्रुप में सबको दिख रहा है इस आदमी ने तो कुछ किया ही नहीं है, तो खुद ही से अंदर पहले दिन कुछ नहीं किया, दूसरे दिन तीसरे दिन तो फिर गिल्टी फील होने लगती है, अरे आई एम नॉट कंट्रीब्यूटिंग. ओके, बिकॉज वी आर ऑल्सो आस्किंग योर कंट्रीब्यूशन डेटा, राइट, हु हैज़ कंट्रीब्यूटेड वॉट. क्योंकि मेरे को 30 साल का अनुभव है, तो मैं देख करके बता दूंगा ये 5 लोगों का काम है, 3 लोगों का काम है, 2 लोगों का काम है, राइट. Even if you use ChatGPT, okay, so that is also easy, one can catch easily, right? Okay, so that's about project. Anyway, now let me start with the double integration. Okay. So just like that, we have Riemann integration, right? A to b f of x, this is the area under the curve y is equal to f of x, right? Same idea, we are going to now do it for double integral. So I am forming what is known as rectangle. A definition of rectangle is what? All those points in the plane r square where a is ranged from, so where x is ranged from a to b and y is ranged from c to d, right? A normal definition of x की वैल्यू फिक्स है, y की वैल्यू फिक्स है, तो क्या होगा, एक टुकड़ा आएगा ना प्लेन का, रेक्टेंगल. ओके, दिस इज ए रेक्टेंगल. If let f be a function defined on this rectangle R. Now for simplicity I am assuming this f of xy is positive. And remember, we have done the same thing for when we are doing Riemann integration from y is equal to f a to b f of x dx, right? I have assumed that suppose fx is positive, so that you can clearly see the graph of the area under the curve, right? So in order to show that this is a volume, actually I am assuming the same condition. So the graph of f is a surface z is equal to f of x comma y, and suppose S is the solid that lies above R and under the graph of f. So basically, you see, function is positive, right? So surface is something like this, I'm assuming. On the ground there is a rectangle, right? On the plane, on the whole plane there is a rectangle. We have marked the rectangle where x lies between a to b and y lies between c and d, right? Imagine करने को बोल रहा हूँ, मैंने picture draw नहीं किया है, ठीक है? Okay, and the curve is on the top of it, right? Then what you do? S is a solid, so then some solid will be formed, right? Right? Which is above the R. Solid R के ऊपर होगा, base उसका rectangle होगा R, and under the graph of f. Graph of f एक surface है, उसके under. So graph जो surface है, उसके नीचे का portion पूरा bounded by that rectangle. We want to compute the volume of this whole thing. Okay, this surface. Just generalization from the single variable, right? I am now looking at this kind of thing. So basically, mathematically, I can write down S is something like all these points such that we can describe it also. So this is whole surface. At the bottom it is bounded by the rectangle, and the top it is bounded by the surface of the graph of f, which is a surface. Z is equal to f of x comma y. I am assuming f of x y is positive, so we are just only talking about whatever is above the rectangle, right? There we used to do a curve, and we wanted to find the area under the curve, right? So what we need to do, we need to draw a small strip of some length. You divide the interval into sub-intervals and compute the height. Height will be f of x star, where x star is some point in the interval times width of the interval, and then you sum and then take the limit, you get the whole area. Same thing we are going to do. Now we have a solid. Now we want to compute the volume. So what I need to do, I will take a small strip. So basically something like this we are going to do. We divide rectangle into, this is our R. So we divide x and we divide y, right, into certain number of intervals, finite number of intervals, x and y. So we will have something like this. This is on, basically on the ground, on the rectangle, right? So you can see that this is the width of this subinterval, right? Delta x. Similarly, there will be corresponding delta y. So this is a small area of the rectangle below that surface, right? So basically now I have to, you can think of, there will be a sort of a surface going from here up to the
final point of the surface, right? That strip, I want to compute the volume, right? And so then एक strip का volume निकाल लिया, then sum कर लिया and everything, and you get the whole volume, right? Take the limit, right? Getting the idea? So this is the very big, and of course, so यहाँ पे एक generic point लिया, xij star, yj star, all those are mathematical fancy stuff, right? Idea is very simple. Volume निकालना है surface का under the right, so at the ground there is some rectangle, तो rectangle का small element लिया, उसके ऊपर एक solid create किया जो कि top तक गया, वो एक उसका volume निकाल लिया, right? Volume कैसे आएगा? नीचे का area आ गया times f of this value which is the height of the whole thing, right? Multiply कर दिया, you've got the idea, right? So अब इसको लिख लेते हैं, और कुछ नहीं है, simple है. So we divide the rectangle R. So we are dividing A comma B into subintervals xi minus 1 and xi along x-axis, right? With delta x is equal to b minus a divided by n. That's the length. Similarly, CD we divide into yj minus 1 yj subinterval, and width is d minus c divided by n. तो जितना ज़्यादा n बड़ा होगा, नंबर ऑफ इंटरवल्स ज़्यादा होंगे, इस साइज कम होगा, राइट? So we are forming the rectangle Rij, xi minus 1 comma xi, cross product yj minus 1 comma yj, right? So this is nothing but all points x comma y such that xi minus 1 less than or equal to x less than or equal to xi, and yj minus 1 less than or equal to y less than or equal to yj. So this is our Rij, right? जिसका यहाँ से यहाँ तक का लेंथ डेल्टा x है, यहाँ से यहाँ तक का डेल्टा y है, राइट? Rij हमने रेक्टेंगल का एक स्मॉल पीस ले लिया, राइट? This is Rij, and so area of this is delta x into delta y, right? Because this is delta x, this is delta y, so area is delta x delta y. Area of this small rectangle on the whole big rectangle is delta a, right? Delta x into delta y, correct? Now I am taking a point xij star yj star on inside this small rectangle and compute the value of this function, that will be the height, right? Multiply that function height with this area and then sum. So the sample point I am taking this, and then I am computing this value here, f of xij star yij star. Okay, so basically this is the height times delta a, or which is nothing but f of xij star comma yij star into delta x delta y, right? This is the volume of the small strip, right? With the base area is delta a, delta x into delta y times f of xij star yij star, which is the height. So this is the volume of the small strip, right? So overall volume, I can say that overall volume is nothing but summation I is equal to 1 to m, summation j is equal to 1 to n, f of xij star yij star times delta a. This is the approximate sum, because, and this will be better approximation when these subinterval, the size of the subinterval is very, very small, right? Then it will be better. So basically I can say that V is nothing but limit Mn approaches towards infinity, summation I is equal to 1 to M, summation j is equal to 1 to n, f of xij star yij star time delta A. So now we are ready, and this volume is nothing but definite double integral, right? This is definite double integral, right? So we have double integral, so di double integral of f over a rectangle R, f of x comma y dA is limit Mn tends towards infinity, summation I is equal to 1 to M, summation j is equal to 1 to n, f of xij star yij star times delta A. Delta A is delta x into delta y, remember? Right, that is there. So अब इसमें लिमिट की बात आ गई, राइट? सो वन कंडीशन ऑटोमेटिकली कम्स, यू लिमिट, अगर लिमिट एग्जिस्ट करेगी तभी ये वॉल्यूम निकाल पाएंगे, राइट? एंड ऑफ कोर्स दिस वी कैन डू इफ एफ इज कॉन्टिन्यूअस, अदरवाइज नॉट, राइट? सो दिस लिमिट एग्जिस्ट if f is a continuous function. तो बेटर अंडरस्टैंडिंग के लिए एक टी टाइम प्रॉब्लम बनती है यहाँ पे. गिव एन एग्जांपल ऑफ ए फंक्शन, टू वेरिएबल फंक्शन फॉर विच दिस लिमिट डज नॉट एग्जिस्ट. दिस काइंड ऑफ लिमिट फॉर सम ए एंड बी एंड सी एंड डी, तो आसानी से बना सकते हो. कोई भी डिसकंटिन्यूअस फंक्शन ले लो, राइट, बिटवीन दोज limits, right? And then you see that, right, this limit does not exist. So this is your actual volume. So there are some properties which are there. Before actually moving further and giving any other example, I want to just mention those properties. First of all, integral along this rectangle f plus g. So f and g are two variable functions. dA is equal to f dA plus GDA. So sum, you can do individual sum them. Second, a constant times f of x comma y dA is equal to c times, c is a constant, right? Third, if f of x comma y is bigger than g of x comma y for all x comma y in that rectangle R, f of x y dA will be bigger than g of x comma y dA. So these are some simple properties, right? If f of x comma y, g of x comma y are two functions, you sum them and do the double integration, right? It is same thing as you do the individual integration and sum them, right? Very basic properties. So remember this, whenever either we write like rectangle R, or we can also write integration a to b or c to d, right? Those two things. आई थिंक एग्जाम्पल तो नहीं हो पाएगा, बट शायद हम एक मेंशन तो कर ही सकते हैं, एंड मे बी वी कैन डू इट लेटर ऑन. इफ आर इज इक्वल टू x comma y such that -1 is less than or equal to this and -2 less than or equal to y less than or equal to 2. तो अभी क्या करना पड़ेगा, इस कर्व को ड्रॉ करना पड़ेगा, राइट, इन अ सेंस कि how do you find this value or compute the limit and whatever, right? So essentially it is saying that find the volume under this curve, right? तो ये हम बाद में करेंगे शायद क्योंकि अभी हमको इसमें आई नीड टू टॉक अबाउट इटरेटेड इंटीग्रल्स व्हेन वी कैन चेंज द ऑर्डर ऑफ इंटीग्रेशन एंड सो ऑन, then you will have more flexibility how do you compute these double integrals, right? Okay, so I think that's all for today. अगली क्लास कब है? कल. So tomorrow is the last class before exam, I guess. So I have to give you overview thing just like every classes last time we have done, whatever we have covered, right? So I hope that should be fine. Yeah, paper तो तुम्हारा ready ही है, right? Question paper, it's not very difficult anyway this time. Again 4 question ही होंगे paper में, right, as usual. Okay, so paper के ऊपर ही लिखना है, roll number और नाम जरूर लिखना, otherwise प्रॉब्लम होती है, ठीक है? Okay, thank you.